Are you tired of the simodont inaccessibility in the college? Here's to revolutionizing dental training with just a tap. Meet Dentify, delivering hands-on dental simulations right to your fingertips, available anytime, anywhere. The Dentify login page shows the application's secure way of accessing the portal, encrypted with your own Mail and password. The Dentify landing page boasts a cohesive design that allows users to access the app with ease and minimal learning curve. Right off the bat, you can see the Learning Trade search bar, the dashboard, and professors. Learning Trade is a feature of Dentify that allows students and teachers to exchange educational short form videos. Dent Forum, on the other hand, allows the interaction among users and allows them to engage in educational discourse. Dentiplan and My Progress allow users to personalize their own space, plan their day, and see their schedules at a glance. The Simodont page is the app's dedicated drive, powered by cloud storage, allowing the users to sync their Simodont progress to the Dentify mobile app and review their exercises at their own pace. The directory lists all the users, professors, and peers, contacting them with greater ease. The Feedbacks page is an up-to-date and real-time messaging platform for performance feedback and output reviews. Our project proposal highlights challenges at the University of the Philippines College of Dentistry due to limited access to 3 Simodont machines for virtual reality practice. This scarcity makes it difficult for students to review and improve their skills. Our solution, Dentify, is an online platform that lets students replay practice sessions and receive professor feedback. It also offers independent exercises, reducing dependence on the limited machines and promoting flexible learning. For the beneficiaries, it includes the UPCD students as they gain a flexible, tech-driven platform for skill practice with real-time feedback without any care for pressure. Also, with Dentify, professors can efficiently monitor progress and enhance learning outcomes of the students, while UPCD itself improves their program quality and reputation with modern technology. As for the sponsors, the UPCD administration is expected to provide funding and support, while tech providers ensure stability, and research grant funds are expected for development. The IT department is considered a stakeholder as they will maintain the platform, the development team ensures usability, and students and faculty provide feedback for improvement. Together, these groups drive Dentify's success.
Dentify aims to lead innovation in transforming dental education systems, envisioning to revolutionize the theoretical and practical learning experience of dental students in the University of the Philippines, Manila. The goal is to elevate the standards of excellence and inspire a new generation of competent and confident dental professionals. Dentify is a trailblazer in the digital education industry, maximizing the learning potential of students by integrating up-to-date performance reviews, feedback, and a collaborative learning platform. This cultivates a community of learners and educators, fostering lifelong learning and growth. Dentify's goal is to set new standards and raise the bar for dental education, practice, and professional interaction. The team's mission is to create an application that offers a cutting-edge server-based educational enhancement system or SEEs that aims to improve the learning experience of dental students in the University of the Philippines, Manila. It integrates education with social experience to empower students and enhance their comprehension of both the practical and theoretical aspects of dentistry. By incorporating elements such as performance evaluations, feedback mechanisms, interactive activities, and information sharing, the interaction between professors and students becomes more significant, thus elevating the learning experience while also transcending the possibilities of technology and dental practice.
The general objectives of Dentify is to enhance the educational experience of dentistry students of UPCD by bringing the Dentify application's 4 pillars of ease: education, application, social experience, and empowerment, providing accessible virtual practice sessions and learning materials, timely feedback from instructors, and collaborative learning opportunities for skill development, all incorporated with Simodont dental trainers. The specific objectives of Dentify are as follows. First, to create an educative and social interactive platform. Dentify aims to provide an educative and interactive platform for UPCD students, offering access to Simodont practice data, learning reels, exercises, study plans, and a feedback system to enhance the teaching and learning experience. Second, to build and track strong engagement and satisfaction. We target strong student engagement and user satisfaction within the first 3 months of launch. 75% replace access, 75% exercise completion, 75% feedback, and a SUS score of at least 75 addressed to maximize app utility and effectiveness. Third, to ensure feasible collaboration and integration. Dentify integrates software, hardware, and peopleware, collaborating with university stakeholders, the faculty, IT staff, and students to ensure compatibility and efficiency. Training will empower users to fully utilize and maintain the system. Fourth, to establish a feedback mechanism. A feedback system promotes instructor to student and peer collaboration by enabling meaningful comments on practice sessions, enhancing the social and interactive aspects of learning. Lastly, to achieve within the development timeline. The app's full feature set will be developed within a year with an additional 9 months for training, implementation, and iterative improvements, ensuring a seamless rollout and continued optimization. Moving on to Dentify's Telos feasibility findings and solutions. For technical feasibility, Dentify's core challenge lies in integrating with Simodon simulation data for seamless access to replays, exercises, and feedback. Using cloud-based hosting solutions like Google Cloud ensures secure and scalable data management. A web interface and mobile app will provide accessibility, utilizing React JavaScript and Node JavaScript for an efficient user experience. This integration supports enhanced teaching and learning at UPCD. The project's economic feasibility requires 3 million pesos for software development, 40,000 pesos per month for cloud server hosting, 120,000 pesos for hardware, 25,000 pesos for each faculty training workshops, and IT maintenance staff at 75,000 pesos per month. To manage expenses, phased implementation, university sponsorships, and potential external leasing of Dentify to other Simodont users are viable options. Legal feasibility would entail compliance with the Data Privacy Act of 2012, which mandates user consent, data encryption, and regular audits. Licensing agreements with Simodont will ensure proper integration and use of their simulation features within Dentify, adhering to their terms and conditions. Organizational feasibility involves faculty and students undergoing training to effectively use Dentify's features, integrating it into the existing curriculum. Reliable IT support will maintain app functionality, server performance, and data security to enhance user engagement and academic outcomes. Lastly, scheduling feasibility involves a 4-phase plan. The project will span 1 year and 9 months. Planning and research in 1 month for stakeholder engagement and feasibility studies, design and development in 8 months for feature creation and Simodont integration, testing and quality assurance in 3 months involving student and faculty feedback, and lastly, training, implementation, and optimization in 9 months for system deployment and iterative improvements.
For the SWOT analysis, the project has these strengths. In technology, the University of the Philippines leads with early access to Simodont machines, enhancing virtual reality learning for dentistry students. In resources, the app is easily downloadable, enabling users to access it anytime with an internet connection. In objectives, Dentify can optimize limited Simodont units by allowing students and faculty to review data remotely. In skills, the Dentify community fosters collaboration, skill improvement, and feedback exchange among students and faculty. For the weaknesses, in the processes, the new software requires training, which may slow its rollout. In the objectives, limited personal-patient interaction means the app supplements rather than replaces hands-on practices. In the resources, dependence on technology raises concerns about network issues and the need for robust site maintenance. For the opportunities, in the informations, initial user feedback can enhance the application and user experience. In the processes, Dentify can be incorporated into the dental curriculum as a supplementary tool. In the objectives, collected data can be valuable for analyzing user trends and behaviors in academia. For the threats, in technology, the app's efficacy is linked to the condition of the Simodont machine. Damage to it can hinder the app's functionality. Sync issues, data syncing problems can lead to bugs and file corruption. And in resources, the app's digital nature risks data breaches, necessitating improved security measures to protect user information.
Dentify is a server-based educational enrichment platform designed to enhance dental training at UPCD. This conceptual model outlines the interaction between key stakeholders, students, professors, technicians, and the Simodon software. At its core, Dentify integrates Simodon data with server-based functionalities, enabling features like replay sessions, feedback, and collaborative learning. These components aim to address the challenges of limited machine access and create a more interactive and accessible learning experience. Professors play a crucial role in the Dentify ecosystem by tracking student progress and providing targeted feedback. This ensures that students address specific weaknesses and develop technical confidence. For students, Dentify fosters self-directed learning through session replays and supplementary exercises, empowering them to improve their skills at their own pace. The platform's core functionalities revolve around addressing key educational gaps. Simultaneous integration ensures seamless recording and replay of practice sessions, allowing students to critically reflect on their techniques. The learning plan organizes schedules and fosters consistent progress. Professors can utilize the feedback system to provide session-specific advice, and the learning trade page promotes interaction, creating a collaborative learning environment. Dentify addresses the pressing issue of limited Simodon access at UPCD, where only 3 machines serve the entire student body. This system transforms a constrained learning environment into an on-demand, flexible platform where students can replace sessions, receive feedback, and enhance their skills outside formal practice slots. By overcoming these resource bottlenecks, Dentify ensures continuous learning. Beyond individual benefits, Dentify provides institutional scalability, addressing increasing student population without significant investment in physical resources. Collaborative features like the learning trade page promote peer-to-peer interaction, fostering a supportive community. This ensures that UPCD remains at the forefront of dental education by adopting a sustainable and adaptive training model. Dentify is more than a solution for today's challenges. It's an investment in the future of dental education. By offering a scalable and sustainable platform, it sets new standards for integrating technology into training, ensuring accessibility, efficiency, and innovation for years to come.
Moving forward to the evaluation of features, usability testing with students and instructors. Usability testing ensures the achievement of the best possible outcomes of end users of applications. Initial usability tests can be implemented before the launch of the system to gather early feedback from a small group of students and instructors. Through this, we can obtain key points on ease of use and accessibility of the application, which can be noted in future version upgrades. This includes tracking how easily tasks are completed and measuring completion times. Positive feedback, high completion rates, and usability surveys will guide future updates to improve the interface and features. Student learning and performance improvement. Pre and post implementation evaluations will measure student performance and learning efficiency, tracking student engagement and how often they use features like performance replays helps determine if the app supports their learning and improves outcomes. Usage analytics and project impact. Key usage metrics such as login frequency, time spent, and engagement with exercises will indicate how effectively the system supports student learning. Tracking student performance and grades in lab sessions will also reveal the application's impact on their academic progress. Feedback from instructors and efficiency. Surveys for professors will assess their experience with providing feedback to students through the application. If Dentify reduces their workload and enhances feedback quality, it will confirm the system's effectiveness compared to in-person feedback methods.
Let's dive into the project plan for Dentify, which follows a structured waterfall development model. First, in the requirements phase, we identified the key needs, enabling students to access Simodot recordings remotely, fostering self-awareness, and providing professors with a convenient feedback mechanism. Next is the design phase, where the focus is on creating a user-friendly interface. This includes a digital repository for recordings of Simodon exercises, simple virtual exercises, and interactive feedback tools. The implementation phase will begin with a controlled release to a small group, allowing us to test and refine the system incrementally before scaling up to the entire student body. Guidelines will be created as well in collaboration with the school admin. Once launched, the verification phase ensures system stability through rigorous monitoring and user feedback, including usability assessments. Finally, in the maintenance phase, the focus is to ensure long-term functionality, promptly addressing technical issues and integrating improvements based on our users' suggestions. To develop Dentify, a specialized team was formed and necessary approvals were secured to integrate Simodon data. A secure cloud-based system was created to upload student practice replays, enabling feedback and self-assessment. After iterative testing with the pilot group, the app was gradually rolled out to ensure reliable adoption for students and faculty.
Moving forward to strategies of assessment and usability studies, multiple previous studies have demonstrated that a system usability scale or SUS can be utilized to gather data on overall satisfaction with the system's performance. This includes a short 10-item questionnaire with each question involving choices from strongly agree to strongly disagree similar to a Likert scale. Indicated in this table are the steps in calculating the SUS score. The final SUS score would range from 0 to 100. A high score would indicate that the system is well accepted by the users. Furthermore, alternative methods of gaining feedback on Dentify from users can also be added, such as interviews from students and professors to further improve the system.
Dentify's development utilizes the IT-POSMO framework to ensure comprehensive resource management. Information is sourced from Simodon usage data to improve feedback and replay features, usability insights from students and faculty, research on digital learning to inform progress tracking, and stakeholder input from UPCD and sponsors to ensure alignment with institution goals. Technology includes a robust server infrastructure for seamless access, integration with Simodon for data management, and scalable tools like JavaScript and Google Cloud for development. Now, processes focus on user friendliness, maintaining feedback loops, and ensuring data privacy to protect sensitive information. Objectives and values prioritize enhancing dental education through an accessible, intuitive platform that blends theory and practice to foster innovation and skill development. Staffing and skills involve developers for technical work, IT support for maintenance, and faculty for educational content. Management systems leverage tools like Microsoft Project to track progress and organize tasks efficiently. Lastly, other resources include financial backing, pilot testing, and tools like Microsoft Project for efficient task management.
Moving on to the constraints and limitations of the project, Dentify is designed to enhance Simodon technology at UPCD by enabling students to review their sessions through video replays and receive in-app feedback from professors. The project focuses on short-term outcomes such as skill development, feedback accessibility, and learning satisfaction. It will not involve hardware modifications, address non-simulation aspects of dental education, or extend beyond UPCD. Due to resource and time constraints, only basic features will be developed initially, with advanced functionality such as AI-driven coaching reserved for future exploration. The project also operates within a constrained timeline of 1 year and 9 months, covering the design, implementation, and initial evaluation phases. Given this time frame, we are focusing on developing a functional prototype and assessing its short-term impact on students' learning experiences. However, this limited period means we will not address long-term effects on skill development or institutional operations. Additionally, advanced features like AI-driven coaching or significant system enhancements are beyond the scope of this phase. Lastly, the development and implementation of Dentify will incur significant costs, including an estimated 3 million pesos for software development and features like Simodont integration, video replays, and feedback mechanisms. Hosting the platform will cost 40,000 pesos per month for cloud-based solutions, while additional hardware such as 3 desktop computers for faculty and IT use will total 120,000 pesos. Faculty training workshops and ongoing IT maintenance will add 25,000 pesos per session and 75,000 pesos per month respectively for 3 part-time employees. To manage these expenses, the project will seek funding through university support, research grants, or technology partnerships and adopt an incremental implementation approach to optimize resources.
This Gantt chart illustrates the timeline for Dentify's development, divided into 5 key phases. The planning and research phase runs from January to April 2025, focusing on foundational tasks such as initial meetings, stakeholders interview, and feasibility assessment. Next is the design and development phase from April to October 2025. Includes system architecture design, user interface planning, core feature development, and Simodont integration, all guided by weekly reviews. Now the testing and quality assurance phase, spanning from July to October 2025, involves internal testing by developers and IT, followed by user testing with students and faculty to refine the platform. From October 2025 to April 2026, the training and implementation phase ensures readiness through faculty and student training, final system setups, and platform deployment. Finally, the monitoring and enhancement phase, lasting from April to October 2026, focuses on gathering user feedback, analyzing usage data, and optimizing performance to ensure the platform's ongoing improvement.
The Dentify system addresses the limitation of having only 3 Simodont machines at UPCD by providing a server-based platform that integrates simulation data into an accessible, interactive digital environment. This platform allows students to replay their practice sessions anytime, fostering independent learning and skill refinement outside scheduled machine use. Professors can provide personalized feedback through learning reels and discussion forums, ensuring continuous support for students. By reducing reliance on physical machines, Dentify optimizes existing resources and creates a connected learning ecosystem that includes students, professors, technicians, and Simodon software. With tools like the learning plan and supplementary exercises, the platform enhances learning flexibility and sets a new standard for technology-driven dental education. Dentify's potential for positive impact aligns with the college's vision of leveraging technological advancements to improve learning and teaching processes. By ensuring long-term educational improvements without substantial additional investments, Dentify stands out as a strategic project that can significantly benefit the UPCD community.
This is the list of our references. Thank you so much for listening, and we are hoping for your help in making Dentify a reality.